Welcome back, Focus Learners. Today, we're diving straight into one of the absolute biggest game changers in all of programming, Python loops. You know, if you've ever felt like coding is just typing the exact same thing over and over, well, get ready to have your workflow completely transformed. Loops are the ultimate tool in your developer toolkit to repeat tasks easily and efficiently.
Okay, so let's really think about this. Have you ever found yourself wanting to repeat tasks easily without writing 100 individual lines of code? Imagine having to process 100 images or, print the numbers 1 to 100 on your screen. Are you realistically going to sit there and type out print 1, print 2, print 3 100 times? No way. That is a fast track to burning out. And that's exactly where loops swoop in to save you a massive amount of time and effort through automation.
So here's our game plan for today's explainer. First, the power of loops. Second, the for loop and range. Third, the while loop. Fourth, controls like break and continue. Fifth, the pass placeholder. And finally, how to put it all together to code like a pro.
All right, let's jump in. Section 1, the power of loops.
Let's kick things off with the first major workhorse of our toolkit, the for loop. So what actually is it? Basically, we use a for loop in Python when we know exactly how many times we want to repeat a task. Its absolute superpower is predictability. When you have a set number of iterations firmly in mind before you even run the code, like, say, analyzing exactly 5 rows of data, the for loop is your absolute go-to.
Let's peek under the hood and trace the logic here. We start up at the top, setting our variable, let's just call it I, to 0. Then we hit a decision point. Is I less than 5? Well, 0 is definitely less than 5, so that's a true. We move down, print the value of I, and then add 1 to it. Then the loop circles all the way back around to the top. It keeps spinning like this until I finally hits 5. At that exact moment, the statement is 5 less than 5 becomes false, and the loop just ends.
And when we look at the actual output of our code for I in range 5, we get 0, 1, 2, 3, and 4. Now you might be thinking, wait a minute, why didn't it print the number 5 itself? Well, it actually did loop exactly 5 times. But since computers start counting from 0, it prints 0 through 4. Pretty cool, right? That gives us our 5 exact, predictable repetitions.
Moving right along to Section 2, the for loop and range.
Now let's talk about the ultimate accessory for the for loop, the range function. This is the engine generating our sequences, and it is incredibly flexible. If we just call range 5, we get that 0, 1, 2, 3, 4. But if we give it 2 numbers, like range 110, it starts exactly at 1 and goes up to 9. And check out this third example. This is fascinating. Range 1, 10, 2. The output is 1, 3, 5, 7, 9. It's literally skipping numbers.
So how exactly is it doing that? Well, it's all about 3 specific parameters: start, stop, and step. Step 1 is your start value, which defaults to 0. Step 2 is the stop value, and this is absolutely crucial to remember. The stop value is not included in your output. It stops right before it. Finally, step 3 is the step value, which determines how much you jump by in each iteration. Master these 3, and you can customize sequences to fit practically any problem.
Let's tackle Section 3, the while loop.
So if the for loop is our predictable workhorse, the while loop operates with a totally different philosophy. We use a while loop when we just don't know how many times we need to repeat a task. Instead of a set number, it just keeps running and running and running as long as a specific condition remains true. It's super dynamic. You'd use this when you're waiting for a specific event, like a user clicking a button or a file downloading.
Tracing the logic here, you'll see the difference. This time, we start our count variable at 1, not 0. The condition asks, is the count less than or equal to 5? 1 is less than 5, so that's true. We print the count and add 1. But notice something super important here. Because our condition actively includes equal to 5, the program actually prints 1, 2, 3, 4, and 5 before the condition finally flips to false and a loop gracefully exits.
Let's put these two titans head to head. The crucial point is choosing the right tool for the job. The for loop? Use that when we know exactly how many times to repeat. The while loop? Use that when we don't know how many times, because it relies entirely on a true condition remaining active. It really is that simple.
Next up, Section 4, Controls, Break and Continue.
Think of these controls as your emergency safety switches. First up is the break statement. Simply put, break is used to stop the loop completely. Imagine your code is just happily chugging along and suddenly a specific condition is met. Boom.
The break statement stops the loop dead in its tracks. It's exactly like pulling the emergency brake on a speeding train. You can see it in action right here. We have a for loop set to range 10. Normally, we know that would print 0 through 9. But inside the loop, we snuck in an if statement. If I equals 5, break. Because of this, the output is just 0, 1, 2, 3, 4, and then it completely stops. Even though the range was programmed for 10, the loop breaks the exact fraction of a second I hits 5. Now let's look at its sibling, continue. Unlike break, the continue statement doesn't derail the whole train. Instead, it simply skips the current iteration and immediately continues with the next one. It's a really quick, breezy way to just skip a single beat to bypass one specific item without ruining your entire loop structure.
Observe the output carefully on this one. We've got 4 in range 10 again, but this time our condition says if I equals 5, continue. Notice what happened. The numbers printed are 0, 1, 2, 3, 4, and then 6, 7, 8, 9. The number 5 is completely missing. The loop hit 5, skipped the print command for that specific round, and jumped straight ahead to 6.
All right, section 5, the pass placeholder.
Okay, the pass statement is actually kind of hilarious because it literally does nothing. Yep, you heard me right, absolutely nothing. It is used strictly as a structural placeholder. Sometimes Python's strict syntax demands that you have a code block written out, like inside a loop, just so the program doesn't crash. If you haven't quite figured out your complex logic yet, you just type pass. It generates 0 output, but keeps your code perfectly error-free while you think.
Finally, Section 6, Code Like a Pro. We've seen how combining the predictable for loop, the dynamic while loop, and these flow control switches gives you absolute mastery. I absolutely love this quote from our source material today. Loops make our code powerful, and they really truly do. By taking these repetitive, tedious tasks and handing them off to the computer to handle in milliseconds, you are freeing up your own brain to tackle the fun, creative logic problems. That is what software engineering is all about.
So here's my final, provocative question to you as we wrap up today's explainer. Will you practice today and code like a pro tomorrow? The concepts are clear, but the real power comes when you actually sit down at your keyboard. Take these incredible tools, experiment with them, intentionally break them and fix them, and put them into practice today. Thanks for joining me, Focused Learners. Keep building, and I'll catch you in the next explainer.